continuing periodic table, and this is very big chapter. I told you in previous class also. I mapped this into 15 different points, and in previous class I told you about 5 points. Now we are starting from point number 6. Look at this point number 6, Mendeleev Periodic Table and Law. Now what it means? I mean to say that if you are told to write what is Mendeleev Periodic Law, or define Mendeleev Periodic Law, or introduce Mendeleev Periodic Law, you can go this way. It is a table of elements made by Mendeleev, in which elements are arranged in the increasing order of their atomic weight, in such a way that elements having similar physical and chemical properties are placed in a group, and it consists of 8 groups and 7 periods. Now, this Mendeleev Periodic Law is based on a law. Mendeleev Periodic Table is based on a law. On what basis Mendeleev made this periodic table is given as a law. What is this? Mendeleev Periodic Law. What is it? Mendeleev Periodic Law. Physical and chemical properties of the elements are a periodic function of its atomic weight. Now, what it means, I want to show you with the help of table. According to Mendeleev Periodic Law, physical and chemical properties of the elements are the periodic function of their atomic weight. What is the meaning? When the elements are arranged in the increasing order of their atomic weight this way, then after certain definite interval, the elements having similar property again repeats. What it means? Just for example, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. After fluorine, sodium has more atomic weight than fluorine, and it is similar to lithium. In the same way, magnesium, which has more atomic weight than sodium, it is similar to beryllium. In this way, after certain and definite interval, the elements having similar property repeats. This is the meaning of physical and chemical properties of the elements are the periodic function of their atomic weight. Now let's talk about the importance of Mendeleev Periodic Table. The first importance is systematic study of the elements. We can elaborate this point this way. Mendeleev Periodic Table simplified and systematized the study of the elements and its compound. And second importance is prediction of the new element, and third is the correction of the doubtful atomic weight. These two importance I am going to show with the help of this Mendeleev Periodic Table. Mendeleev left gap in his periodic table in different places because some of the elements were not discovered at that time, and he told that they will be discovered later in future, and these gaps will be fulfilled. And he named these gaps as Ica aluminium, Ica boron, Ica silicon, and Ica manganese. It means like aluminium, like boron, like silicon, like manganese. Later, these gaps were filled by the discovery of other elements. They were gallium, scandium, germanium, and technetium. Aluminium, Ica aluminium was gallium, Ica boron was scandium, Ica silicon was germanium, and Ica manganese was technetium. In the same way, now I want to talk about third importance. What is it? Correction of doubtful atomic weight. Mendeleev corrected some of the atomic weight of some of the elements. Just for example, at that time, the atomic weight of beryllium was calculated wrong. It was 19.5. And while arranging the elements in the increasing order of their atomic weight, Mendeleev found some difficulty to put the barium in correct place. And later he told that probably the atomic weight of beryllium is not 19.5 and it is recalculated, and really it was found 9.01 only, and then it was corrected and placed in this position. This way there were 3 importance of Mendeleev Periodic Table. Now I want to talk about the defect of Mendeleev Periodic Table or criticism of Mendeleev Periodic Table. There are a few points, just like number 1, anomalous position of hydrogen, number 2, anomalous pair of element, number 3, position of isotope, number 4, position of lanthanides and actinides, etc. Now let's start with the help of periodic table of Mendeleev. At that time, position of hydrogen was criticized. Hydrogen is not similar to lithium, sodium, potassium, etc. because they are metal. Hydrogen is non-metal. That's why it was criticized. And why not hydrogen is taken in this group? Because it is similar to fluorine, chlorine, manganese, etc. This was one criticism. And second, anomalous pair of element. Look at this, cobalt and nickel. Nickel has atomic weight 58.7 and cobalt has 58.9. That's why atomic weight of cobalt is greater than nickel. Then why cobalt is taken first and nickel gone back? This was criticized because periodic table was made in the increasing order of the atomic weight of the element. And third criticism was the position of isotope. Position of isotope. If Mendeleev periodic table is made in the increasing order of the atomic weight of the element, then why isotope are not taken in the table? Because isotope has different atomic weight but same atomic number. Just like hydrogen has got 3 isotopes, protium, deuterium, tritium. Atomic number is 1 but atomic weight is 1, 2 and 3 respectively. Why are they not taken in the periodic table? It was another criticism of that time. And another criticism, there was no any place for lanthanides and actinides in Mendeleev periodic table. That was also criticized. And another criticism, some of the similar elements were placed in different group, but some different elements were placed in the same group. Look at the table again. Lithium, sodium, potassium, these elements are highly reactive elements and they are metal, but copper, silver, gold, they are very less reactive and not comparable with lithium, sodium, potassium, but all of them are placed in the same group and it was criticized. In the same way, copper and mercury, they are similar but they are placed in different group and this was also criticized at that time. Let's talk about modern periodic table and the law of modern periodic table. What is modern periodic table? You can write this way. It is a table of all known elements which are arranged in the increasing order of their atomic number, not atomic weight, increasing order of their atomic number in such a way that the elements having similar electronic configuration are placed in a group. This is the introduction of modern periodic table. And the modern periodic table is based on a law. What is this law? The physical and chemical properties of the elements are the periodic function of their atomic number, not the weight. This is the law of modern periodic table. Now, I want to explain this with the help of periodic table, modern periodic table, and I'll tell you characteristic also. In modern periodic table, elements are arranged in the increasing order of their atomic number, just like 3, 4, 5, 6, 7, 8, 9. Everywhere you can see that in the increasing order of their atomic number, these elements are arranged. And next thing, after a definite interval, the same property repeats. That's why in modern periodic table, what can we say is law? Physical and chemical properties of the elements are a periodic function of their atomic number. Now, I'm talking about the characteristic of modern periodic table. What are the characteristics? Number 1, elements are arranged in the increasing order of their atomic number. Number 2, there are 9 groups and 7 periods in this periodic table. How 9 groups? I told you in the previous class. And number 3, lanthanides and actinides are placed differently at the bottom of the periodic table. Number 4, elements are not only classified into groups and periods, they are classified into 4 distinct blocks. Look at this, S block, this 2 group forms X block, this 6 forms P block, this is D block and this is F block. And the elements of group 8 of Mendeleev periodic table was taken as transition element here, in between the group 2A and 3A. These are the characteristics of modern periodic table. Let's talk about differences between modern periodic table and Mendeleev periodic table. This is modern, this is Mendeleev periodic table. Elements are arranged in the increasing order of their atomic number in modern, but elements are arranged in the increasing order of their atomic weight in Mendeleev periodic table. Now, modern periodic table, it provides a fixed place for the lanthanides and actinides. But there is not a fixed position for the lanthanides and actinides in Mendeleev periodic table. Okay, number 3. There are 7 periods and 9 groups of elements in modern. There are 7 periods and 8 groups in the Mendeleev periodic table. Number 4. Isotopes were not taken in the table because elements are arranged in the order of increasing atomic number but not according to atomic weight. But in Mendeleev periodic table, position of isotope was not clear. Now in modern periodic table, number 5, each element has its own place in the periodic table in a series that is from 1 to the last. But in Mendeleev periodic table, in the place of one element, there were 2 or 3 elements. Look at this, here 2, here 3 elements. And number 6, elements are divided into groups, periods and 4 distinct blocks in modern periodic table, but in Mendeleev periodic table, elements were divided into groups and periods only. Now let's talk about 2n square rule. This is a rule which gives the maximum number of electrons which accommodates the particular orbit of the atom of the element. What it means? It means how many maximum electrons can be accommodated in particular orbit of the atom. Now I want to show this with the help of this mathematical expression. Look at this. For the first orbit, n equal to 1. That's why 2n square rule becomes 2 into 1 square equal to 2 into 1 equal to 2. It means first orbit can hold maximum 2 electrons. In the same way, for second orbit, n equal to 2. 2n square rule gives 2 into 2 square is equal to 2 into 4, that is 8. Second orbit can hold maximum 8 electrons. In the same way, third orbit, n equal to 3, and it can hold maximum 18 electrons. After 2n square rule, now I want to stop this class because the length of class is being longer and longer. Now next class we'll start with point number 10 and we'll complete periodic table. Today this much. Thank you.